Everyone, and welcome back. In this lecture, we'll build our logistic regression model. If we look at our data set by calling the head method, we see that we have 6 columns. We'll use the admittance or admit column as our target, and we'll use GRE, GPA, and the 3 rank columns as our feature. Okay, so we'll save the features in one variable and we'll save the target in another variable. And then we'll use the train, test, split method to split our data set into training and then testing sets. Once we have that, we'll instantiate our logistic regression model and then train our model on the training data sets, and we'll make predictions. That's what we'll do. The first thing we'll do is import the train test split from cross validation. Let's do that. So from sklearn dot cross validation, we'll import train test split, train underscore test underscore split. Okay. Next, let's save our features in a variable called x. Our features will be GRE, GPA, and the 3 rank columns that we just saw. So GRE, GPA, rank 2, rank underscore 2, rank underscore 3, and rank underscore 4. Those will be our features, whereas our target will be the admit column, which represents admittance. Okay. Now that we have our targets and features, we can split our data set into testing and training data sets. We'll use the train test split method, and then this method accepts our target and feature, and we can pass the optional test size and random state attributes or parameters. So for test size, let's pass 0.3. So we'll use 70% of our data for training and 30% of our data set for testing. And then for the random state, let's pass a value of 23. So you can pass any value. If you want to get the same result as me, you need to pass 23, but we can pass any value for that. And once we split our data, we'll save them in 4 variables called xtrain, xtest, ytrain, and ytest. Xtrain, xtest, ytrain, and ytest. You can save it in any variable that we want, but these are common variables. If you look at the scikit-learn's documentation for train test split method, they use these variables: xtrain, xtest, ytrain, and ytest. But feel free to use any variables. The important thing is to keep consistent with your variables throughout your model. Okay, so later when you do predictions, make sure to pass whatever variable you define here. Okay, now if we print the shape of our xtrain, for instance, we'll see that it will be, we mentioned that we'll use 70% of our data set for training. So the shape of xtrain will be 70% of 400 by 5, which is the number of columns. So if we run this, we have 280. So it's a 2-dimensional array, 280 by 5. 5 is the number of columns that we have, and 280 is 70% of 400. Okay. Similarly, if we print xtest.shape, we mentioned that we'll use 30% of our data set for testing. So the shape of xtest will be 120 by 5, 120 by 5. Similarly, if we print ytrain.shape, we'll see that it's a one-dimensional array. It will just be 280, whereas the shape of y test will be 120. Again, it's a one-dimensional array, 120. Again, this is all derived from our x and y, right? So if we try to print the shape of x and y, let's first print the shape of x, print x dot shape, and then y dot shape. You'll see that the shape of x is 400 by 5, whereas the shape of y is just 400. So this is two-dimensional array and y is one-dimensional, right? 400 by 5 and just 400. So these numbers are 70% and 30% of our data set. Great. Now that we have split our data set into training and then testing data, we'll instantiate our logistic regression model and then train on the training data set. First, we'll need to import logistic regression from scikit-learn. So from sklearn dot linear model, linear underscore model, import logistic regression. Okay, that's in the documentation, how to import it, where to import it. Okay, you don't need to memorize this. So from sklearn dot linear model, import logistic regression. Now that we have imported logistic regression, let's create an instance of the logistic regression class. Okay, and we'll save it in a variable called model. So model is equal to logistic regression. So this is an instance of our logistic regression model. Okay, and you can read more about it on the documentation here on scikit-learn. Okay, scikit-learn that linear model has our logistic regression class, and these are all the optional parameters, and the descriptions are in here. Okay, you can read more about it here. Great. Okay, so if you call your model now, you will see all the parameters used in your logistic regression model. You have the C value for regularization, class weight, and all of this. Okay, now that we have created an instance of our logistic regression model, the next thing we'll do is use the fit method to train our model on the training data sets. So we'll call the fit method on our model and then pass our training data sets, which are xtrain and then ytrain. Now that we have trained our logistic regression model, the next thing we'll do is call the predict method on our model and make a prediction by passing the testing dataset, the x test. Let's do that. So model.predict, and then we'll pass x test. So we'll be using the testing dataset for making predictions. Okay, that's why we divide our dataset into training and then testing. So we can use the training dataset to train our model, and we use the testing dataset to test our predictions. So we don't use the same dataset for both training and then testing. Okay, that's why we separate them into training and then testing. We'll see our model's prediction on the new dataset. Okay, so this dataset, our model has not seen this dataset. This is new. So we use that for our prediction. Okay, that's the importance of splitting your dataset into training and then testing sets. Okay, in any kind of model. And let's save this in a variable called prediction. So prediction is equal to model.predict. Great. Next, we need to evaluate our model, right? Our logistic regression model. We need to evaluate its prediction. For that, we'll be using what's known as classification report. Okay, this classification report will tell us the precision, recall, and F1 score values for our logistic regression model. Okay, first, we'll need to import classification report from scikit-learn, and it's in the metrics library. Let's do that. So from sklearn.metrics import classification report, classification underscore report. Okay, and this classification report takes the values, your actual and prediction values, and then it will print out your precision, recall, and F1 score. Okay, so we can simply say print classification underscore report, and then pass your y-test, which is the actual value, the actual admittance value, and then our prediction from our model, and run it. So this is your classification report for our logistic regression model. Precision, recall, and F1 score. So here it splits it by, for the two values for our admittance, not admitted, and then one is admitted. So we see that our model did great for the not admitted students. We see we have a precision of 77% for not admitted, a recall of 90%, and F1 score of 83%, whereas for the admitted students, the precision was 50%, recall was 28%, and F1 score 36%. And here you have the average of your entire model. So the average is 70% precision, recall value is 73%, and F1 score is 71. So these are low scores. You can read more about what precision, recall, and F1 score mean on Wikipedia, or you can refer to the scikit-learn's documentation. So in short, precision is the ability to not label as positive a sample that's negative. Okay? Whereas recall is the ability of your classifier to find all the positive samples. And you can read more about precision and recall and F1 score values on Wikipedia. But this is one method that we use to evaluate our logistic regression model classification report. Okay, we'll see classification report in some other models in the future lectures also. But this is generally a low score. So the higher the scores are, the better your model will predict the values. Okay. So now we have 70% on average for precision. Our model predicts 70%, recall 73%, and F1 score of 71%. So this is what we have based on these features: X, GRE, GPA, and the 3 rank columns: rank 2, rank 3, and rank 4. So if I go to the beginning of this notebook, when I introduced, I mentioned that we'll start by exploring our dataset and visualizing, and then we'll create a logistic regression model. And for evaluation, we used precision, F1 score, and recall. And here we have what if we consider less features. So here basically we only have 3 features, right? GRE, GPA, and rank. Even if we have 3 rank columns, we have 3 features, right? I'm taking rank as 1 feature, but we have split it into 3: rank 2, rank 3, and rank 4. Rank 4. Do you think we'll get a better classification report if we only consider, let's say, just GRE and GPA as features? What do you guys think? So we'll see that in the next lecture. We'll build a model using only GRE and GPA features and compare our model with this model and see if it can do a better result in the classification report. Thank you, everyone.